So just like you've learned your times tables and everything else by practicing them, rules of indices, they are fairly straightforward once you practice them, and you just learn one of the power series, and then the patterns work for any number. So what I mean by a power series, let's take the power series of 2. Okay, so power series means that you're looking at different powers as you come down the patterns. So 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0, 2 to the power of -1, 2 to the power of -2, and so on. So this will be known as a power series. So it's the power series of 2 in this case. But I could have replaced the 2's with 10, 20, doesn't really matter. The patterns will be working in the same way. So what we need to notice is this. 2 to the power of 5 we recognise means 2 times 2 times 2 times 2 times 2, which gives me 32. 2 to the power of 4, 2 times 2 times 2 times 2, which gives me 16, and so forth. So basically, as I keep coming down the power series, I stop multiplying by 1 more 2. So in other words, as I come down, I'm dividing by 2 all the time. So 2 cubed will be 8, 2 squared will be 4, because I halve each time dividing by 2. 2 to the power of 1 is 2. 2 to the power of 0, well remember, we're halving because of the way the pattern works, so that'll be 1. 2 to the power of -1, again we're halving, so we're dividing by 2, so that will actually be a half. 2 to the power of -2, well that'll be a quarter. Again, half of a half is a quarter. So recognise though that a half is actually the same as doing 1 over 2 to the power of 1, because 2 to the power of 1 was actually 2. 2 to the power of -2, well that's 1 over 4, but that's actually the same as 1 over 2 squared, because 2 squared was 4. So from this power series we get some patterns that are really important for rules of indices. So the general rules of indices that you need to be familiar with for your exams are that anything, so A can stand for any number, anything to the power of 0 is always 1. So that means things like 10 to the power of 0 is 1, 7 to the power of 0 is 1, x to the power of 0 is 1. Anything to the power of 0 is always worth 1. Again, that's because of the way the series works. Keep halving down here. 2 to the power of 0 was 1. If I put 10 there, I'd end up with 10 to the power of 0 being 1, and so forth. The next important rule to remember from this is the negative rule for -1. Anything to the power of -1 is always 1 over whatever it was. So we saw here that 2 to the power of -1 was a half. So if I've got 2 to the power of -1, it's just 1 over that. So the negative cause is 1 over, reciprocal 1 over 2. So if I've got 7 to the power of -1, then it's 1 over 7. If I've got 10 to the power of -1, it's a tenth, 1 over 10. So that's an important rule as well, the negative rule. If I have just a power 1, then it's just the thing it was, because I've only got one of them. So therefore, if I've got 7 to the power of 1, it's 7. 64 to the power of 1, it's 64. So those are important rules that you guys need to learn and remember to convert anything that they tell you. Things like if they said to you in the exam, do 7 to the power of -2, then that means 1 over, because of the negative, 7 squared, and therefore it's going to be 1 over 49. So those are the kind of rules that we need to work with. The other rules of indices we need to work with are where we've got something that's being to the power of another number to the same base. Remember, these are called base numbers. These are called powers. So when we've got the same base numbers, then we can add the powers. So basically, if I've got something like 7 to the power of 4 times 7 to the power of 3, I won't do 3, sorry, I'll do 7 to the power of 8. So 7 to the power of 4 times 7 to the power of 8, then because they're both powers of 7, then I can rewrite it as 7 to the power of 4 plus 8, which will give me 7 to the power of 12. Again, the reason why that worked, 7 to the power of 4 is like writing 7 times 7 times 7 times 7. 7 to the power of 8 is like writing 7 times 7 times 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6, and then another one. And altogether I've written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sevens. And it's much better to write 7 to the power of 12 than write all of that out. So the timesing rule works in that way when you're working with the same bases. The other rule to be familiar with is if I'm dividing. So if I've got something that to the power of divide by something to another power, then the rule is that I take away the two powers because I've got the same bases. So if I've got something like 10 to the power of 4 divide by 10 to the power of 8, then that's the same as 10 to the power of 4 take away 8, which is 10 to the power of -4. So again, you know, the rule works in that way. And if I want to see that rule working and the way it works, then 10 to the power of 4 is like doing 10 times 10 times 10 times 10, dividing. 10 to the power of 8 is like doing 10 times 10 times 10 times 10 times 10 times 10 times 10. So 1, 2, 3, 4, 5, 6, 7. So another one. And the way division works, remember, 10 divided by 10 is 1, so they cancel to 1. 10 divided by 10 is 1, that cancels to 1 again. 10 divided by 10 is gone. 10 divided by 10 is 1. So on top here, I'm left with the number 1. And on the bottom, I'm left with 10 times 10 times 10 times 10. Well, that can be written shorter as 10 to the power of 4. So again, notice the negative power, 1 over whatever it was. So this has got 10 and a 4 in it, so that's why we got 10 to the power of 4, and the negative is telling us to do 1 over it. So that's a quick reminder about the rules of indices that you guys need to learn. So understand how the power series helps us to see the patterns. Then learn the rules. Anything to the power of 0 is 1. Anything to a negative power of 1 is 1 over. Anything to the power of 1 is the number itself. When you're timesing with the same bases, then you can add the two power numbers. And when you're dividing with the same bases, you can take away the two power numbers. And there's some examples. So learn your rules of indices, guys.